viewers. I'm back again with our experimentation series. We're now in the second series, and today we want to perform a very simple practical experiment. And through this experiment, I'm sure we'll be able to understand the terms, the different variables that we looked at. And we are also going to learn how to design and carry out a practical experiment. So when you're experimenting, remember we said you are carrying out an investigation in order to gain evidence for ideas. So today we want to look at the reactivity of different elements, the elements which are on your periodic table. I have a few here, and we want to look at how reactive they are, compare their reactivity, so that at the end of the day, we can have our reactivity series. And the elements which I'm going to deal with today, we are going to look at, we have iron, chemical symbol, Fe, we have zinc, Zn, we have lead, Pb, we have copper, Cu, and magnesium, which is Mg. So these are the elements. At the end of this session, you should be able to place them in order of their reactivity. And we are going to determine their reactivity by reacting with dilute sulfuric acid. I'm using 1 mole medium cubed, 1 molar sulfuric acid. Okay, so as you can see, our objective at the end of the day, we want to place these elements in order of their reactivity. And we say we are going to use sulfuric acid. So what is our aim? Every experiment must have an aim. What is it that you want to achieve at the end of the day? What is it that you want to find out at the end of the day? So every aim must have the independent variable as well as the dependent variables clearly stated or clearly laid out. Okay, so the aim. To determine the reactivity of elements using sulfuric acid. That's what we want to do. We want to determine the reactivity of some elements, and we are using their reactions with sulfuric acid. So this is our aim. And from our aim, we must now be able to look at the materials that we will require in order to perform this task. And definitely we need the metals. So we have our magnesium, we have our copper, we have our lead, we have our iron, and we have our zinc. Then definitely we need our 1 mole medium cubed sulfuric acid. Okay. And the other apparatus that you will need, where can we carry out the experiment? We can use test tubes, and this time I'm going to use boiling tubes. Okay. We also need to know the quantity of the acid that we are going to use. As a result, we also need an apparatus to measure liquid volume. And I'm sure from the topic on measurements, you know a different number of apparatus which can be used to measure liquid volume. And today I'm going to use a syringe to measure my volume. And which dependent variable are we going to monitor? Which is going to be influenced by the different reactivities of the elements with the acid. So today we are going to use a ruler. Okay, and we also have a stopwatch for time and the materials that we are going to need. Then we also need now to have the method or the procedure. In the procedure, we are going to show the step by step, these different steps that we are going to perform so that we can get our results. Okay? So, the first step, we are going to label 5 boiling tubes. Label 5 boiling tubes, and we label them A to E. Then using a syringe, measure 10 cubic centimeters of sulfuric acid and pour it into each tube, into each test tube, A to E. Then we are going to take each metal in turn. So we are going to take, we can start with copper. Let's take copper and place it into tube A. At the same time, start the clock. At the same time, start the clock. After 3 minutes, measure the length. Measure the length of the foam or froth produced. Enter your results in table 1. Enter results in table 1. Okay, and we are going to repeat steps. Repeat steps 3 to 5 using the remaining metals. So basically, that is our procedure. But for every practical work, you are also going to have your results. Hence, you also need the table. In this case, we are going to present our results in the form of a table. I hope you remember the topic on data presentation. So this time I'm going to use a table. So before we do, it's convenient for us to create the table of results where we are going to enter our results. Whenever you are creating a table must have a heading. What is it all about? So here I simply say the froth height, since that is the one that I am determining. Okay, and on my table I have columns and I have rows, and again I have put labels so that you know what column is representing what quantity. Okay, so we're now going to do the experiment. So we said, so this is our sulfuric acid, this is my syringe. Whenever you're using any measuring instrument, it's very important for you to determine what the smallest unit is representing, especially if in the event whereby you might need to take values which are in between. the calibrations, or in between the calibrated values. So my syringe is starting from 0, 1, 2, and in between we have a line. So it's like 1, 1,5, 2, 2,5, 3, 3,5. Basically, this is how it reads. So if a value comes in between two lines, then it will be 0,25. If it comes in between, for example, okay, and this is our 0,5 mark. So if the liquid comes in between these two lines, anywhere in between the two lines, then it will be reading 0,25. So with the syringe, our volume is going to be recorded correct to 2 decimal places. Okay. So if you want to use the syringe, please make sure that you push the plunger down, completely down. It should be completely down. And then I'm going to immerse it in the solution which I want to draw. Please let it be completely immersed, otherwise you will drop my air bubbles. Okay, so I'm pulling and now sucking and filling my syringe. It's a bit difficult, but I must fill above the 10 centimeter mark so that I am sure that I have the 10. Now I must go back to the 10 because I've drawn more than. So I now release. In releasing, I'm pushing the plunger down to release. Okay. Okay, and I have to look at the meniscus, the black, which is inside. So now it's at 10, and now I'm going to put it in the boiling tube, which was empty. Okay. I'm tilting because in my acid I added a frothing agent to make my results more observable. Okay, and we said we are going to start with, I've already filled the others a bit earlier on to save on time. I'm going to start with copper. So I'm using copper tannings. And we said we want the reaction to last for 3 minutes. So I have my stopwatch here, and as soon as I'm pouring, I also at the same time I'll start the clock. So here we go, and there goes my clock. And I must swirl a bit so that I mix. Okay, completely mixed. Immersed. So we are going to leave this for 3 minutes. Okay. So the next element, according to my table, is zinc. Unfortunately, I was not able to find granules. I obtained the powder. So if the results are too different, this might also be a possible reason. Okay, well, after 1 minute, I'm adding this one so that I give myself time to record. So this is my zinc, and again I swirl a bit to encourage the reaction. And I will swirl this again. Okay, that is my zinc. Oh, look at Mr. Zinc there, it's really coming up. Okay, then for copper, you can even check the bubbling. There are no bubbles really which are being produced in here. Then after it's 2 minutes, I want to add the third element, which is lead. Okay, so let's see, my 2 minutes up. I'm going to add PB, they are granules. Okay. I tried to weigh 0.25 grams of each element. So this is my lead. At 3 minutes, I'll weigh the froth in my copper. Let's see if there will be any. So far, nothing. Even any form of bubbling, there is no form of bubbling. But let's look at this one closely. I think you can see things rising to the top. You can see the bubbles rising. Okay, I'm sure you're going to explain the source of those bubbles. Okay, the reaction is proceeding nicely. Okay, agitation increases the rate of the reaction. Okay, 3 minutes up for this one. I'll measure that one in 4 minutes. Is there any froth for me to measure? Is there any? I can't find any. So for copper, the height of the froth, I'm going to write 0 centimeters to translate to 0 millimeters. I was not able to find any. Then at 4 minutes, I will measure for zinc. Okay, then I'm going to add my iron into 4 minutes is now up. Let me measure for zinc so that the time factor remains the same. Okay. I'm going to start measuring from where the froth is beginning to where it is ending now. Okay. The 0 mark at the beginning, and this is 9 millimeters. It is 0.9 centimeters. It is, we have to convert into millimeters. Okay? Okay? Then sub G. I'm going to put iron. I have an iron wire. Okay, here it is. I'm going to put it into G. Okay. Hey, oh, look at the bottom. Look at the bottom. Can you see the fast bubbling? Wow, nice. Okay, let's compare the zinc, the lead. Look at the way the granules are bubbling. Yes, they are being formed, but very slowly. So much that, yes, there's a bit of froth. You can try to measure it. This is the next one. That's about a millimeter. Okay? About a millimeter. For this one, and I have to prepare this edge. Five minutes, so 2 more minutes, and I'll set up. If we recorded for the zinc, yes, we've also recorded for the lead, 0.1, which is translated to 10 millimeters. So wait for the iron, and then as you are waiting for the iron, I can also now load the final one. Go to this one, other empty one, which is my E, and in my E I'm going to put my magnesium. Okay, Mg, where are you? Okay. And the iron is ready to be measured, mixing a bit. Oh, let's see how the guy runs. Okay, this is my iron. 3 minutes up. Okay. Wow! Oh, can you see how explosive this region is? Oh, it's hot. It's also hot, guys. It's also hot. It's hardly 2 minutes. It's hardly 2 minutes. So I don't know how are we going to do this. But it's already spilling over. Okay, it's already spilling over. So at the end of the day, I simply have just to measure the height of my boiling tube. Okay, I need more light. Okay, it's not yet 20, this is 10, 11, 12. So that is the 13th mark. So about 14, 15. Okay, 15. But I'm sure you can see that you can even put more than 15 because some is already spilled over. Iron, we got 0.60, in this one we got 15, 50. So, convert into millimeters. So this was our experiment. So we now have to analyze our results. Okay, we have to analyze our results. We can now place those to the metal identity, then height. I want to use centimeters, but you please convert. Okay, so let's put the tubes now in order. So the one with the highest is tube E. Okay, the metal, magnesium with 15,5. Then followed by zinc, which is B. It had 0.90. This was followed by iron, which is D, which is 0.60. And this was followed by C, PB with 0.10. And the list A, copper with 0. Okay, so using our heights, we can now tell which metal is the most reactive and which metal is the least reactive. Okay, so magnesium is the most reactive metal on the list of the metals which I brought, followed by zinc, then iron, and lead, and copper is the least reactive. And from this experiment, we can also conclude that copper does not react with dilute acids, and if that's true, it's in your textbooks, and it also does not react with water. That's why copper is usually used for pipes, water pipes. Copper is used to make those pipes because it will not corrode since it does not react with water, and it will also not react with dilute acids. Okay, copper is also used in cables, electrical cables. It will not corrode because it will not react, but it's also a good conductor. Okay, so this is the experiment. So at the end of the day, we can now conclude. In our conclusion, we have to now determine the reactivity order of reactivity using our results, and we can now write the order in terms of decreasing or increasing order. So with decreasing order, I will simply write I use less than signs. But if I was to represent this order in terms of increasing order, then it will mean I have to start with the smallest copper. Is it smaller or greater? So we use greater here, isn't it? Greater. Excuse me for that. The mathematician teachers, please. Okay, then copper less PB less. Okay, this is not the increasing order. Decreasing order, magnesium greater. You always point at someone who is younger than you. You cannot point at someone who is older. So here I'm pointing at copper because it's lower in the reactivity series. Okay, so from this reactivity series, we can now explain some of the reactions, like the displacement reactions. If we take copper sulfate and we drop an iron nail in copper sulfate, you are going to observe that the iron nail is going to be coated with a brown coat. Why? Because the iron is more reactive than copper. Hence, it will displace the copper ions from a solution of its ions to form copper. Okay, so let's look at the reaction which is responsible for the bubbling plus sulfuric acid. So because we are reacting sulfuric acid, the salt that we are going to form is magnesium sulfate plus hydrogen gas. This is upper, this was upper, and this was a solid, including the state symbol. So we have to see if the equation is balanced. In balancing equations, we have to look at the number of atoms for each element. So this side, the coefficient, there's no coefficient here, it means it's 1, 1, 1, 1 of each. So I have 1 magnesium in this end, I also have 1 magnesium, I have 1 the sulfate ion, I also have 1 there, and I have 2 hydrogens, and I have 2 hydrogens. So the reaction is balanced. Okay, and in this reaction, who was the limiting reagent? Our magnesium completely dissolved. The magnesium completely dissolved. Okay, the magnesium completely dissolves. So if the magnesium completely dissolves, then it means that the magnesium was the limiting reagent, and it will mean we have excess sulfuric acid, so some of the acid remain unreacted. Okay, so the gas responsible for the bubbling is hydrogen gas. In this experiment, the independent variable that we're manipulating with the different metals, these are the independent variables because these were the ones that we were changing. And the dependent variable was the height, the froth height. Because the height of the froth depended on the type of metal used. Okay, so this, the independent variable, the different metals that we were changing, and the dependent variable was the froth height. Now let's look at some of the controlled variables. These variables, the controlled variables, are the ones which we said should have been kept the same. So one of them, we used the same volume of acid. We added 10 cubic centimeters into each test tube. That's controlled, because if the amount of acid was different, maybe that would have produced different results. 1, 2. So my controlled variables. Some of the controlled variables in this particular experiment. So we said 1, the height, the volume of acid used. Okay, we used the same volume. I also stated that I try to use the same mass. And what else should also have been kept the same, though I've already stated that I was not able to make that one remain the same. The surface area provided by the metal should also have been the same. If I was using granules, I should have used granules throughout. If I was using powders, I should have used powders throughout. If I was using a hard solid, I should have used a hard solid type throughout, so that any of those factors will not also contribute to the differences in the froth height. Okay, and also the other time, the time taken. The time taken for the reaction to occur. We try to make each reaction go for 3 minutes before taking the time, the froth, sorry. So time taken also falls under controlled variables, because we're taking the height after every 3 minutes. Okay, because if the time taken was also different, again that would also contribute to some differences in the height. So I now hope you understand what we meant when we looked at the independent, the dependent variables, as well as the controlled variables. So for those who are asked to design experiments, I'm sure you can also see how you can design your experiments. In the procedure, when you're taking volumes, please, you must also state the quantities as well as the measuring instruments that you are using. Okay. So for today, we end here. Please. So the task I'm leaving you with is 1. I want you to calculate the number of moles of sulfuric acid present in 10 cubic centimeters of the acid. And remember, the concentration is 1 mole per dm cubed. Remember, the concentration is 1 mole per dm cubed. Therefore, to calculate the mass of magnesium, calculate the mass of magnesium that reacted. Calculate the mass of magnesium that reacted. 3. Calculate the volume of hydrogen gas. Calculate the volume of hydrogen gas produced when we are operating at RTP. And at RTP, we are going to use the molar gas volume. 1 mole is equals to 24 dm cubed. And number 4, please describe a test. Describe a test for hydrogen gas. How can we conclusively say the gas produced is hydrogen gas? So guys, if this is your first time connecting to this channel, please subscribe, like, press or click the button, and also please share. Okay, write your answers in the comment section. Then I'll give you the answers in the next series. So this is our 2nd series. So remain tuned. I'll meet you again in the 3rd series. Thank you.